All right, let's get started with this re-recording of the presentation that I held at FMX 2022. All right, so the topic of the presentation is 3D urban environments, challenges and solutions. There was a quick shout out to another presentation that Esri held with the title of Creating High Quality Urban 3D Environments, where I was also a part of it. So we are going to skip this one because it's not live at FMX anymore. All right, let's dive into this part here. Cool. My name is Matthias Bühler and I am the founder and CTO of Urban. My background is actually in architecture and I am a city engine specialist and Esri partner. Meanwhile, I've been doing urban 3D modeling mainly procedurally for about 13 years. And to go kind of into what we are doing as a company. So we are not a visual effects studio, or we are also not a game studio. What we actually do is we specialize in 3D architecture uniquely or solely. And in extension to that, we are also diving into the creation, or more and more into the creation of large-scale 3D environments. So we have two business units, and they are, the first one is Urban Solutions, that is providing services and consulting for a lot of different topics in the field of 3D GIS, urban planning, architecture, and the entertainment industries. And then on the other side, there's the second business unit, that is Urban Studios, which provides 3D content. So that would be pretty much off-the-shelf 3D content. Just a couple of examples here. So this is of King Sakir. This is, or what you see actually slightly blurred in the background, is a cartoonish or a cartoon-inspired representation of the city of Istanbul in Turkey that we created for this kids cartoon movie that was in the cinemas. All right, what we see here is a second example of actually a game where we helped developing about 500 3D buildings for the game in 3 different time eras, and that game is actually a Swiss production by Urban Games, and the game is called Transport Fever 2. This one here is for the city administration of Zurich. This is a historic project where we helped with some consulting and with the help of, for example, creating a procedural rule for the tool called City Engine to help with the creation of about 99% or over 99% of the building representations that you see here, everything modeled and textured procedurally. And in extension to that, we also helped with retexturing some of the landmark buildings, remodeling some of the landmark buildings. And in extension to that, what you actually see here playing is the animations and some of the static renderings that were then used for visualizing the project realistically. Let's talk about the challenges of creating 3D urban environments. So first and foremost, what I think is very, very important to look into is, or are the so-called building typologies. Now, what do we mean by building typologies? Looking at this still frame here of the movie Dread, one of my all-time favorites is, and it's kind of a mixture between an actual helicopter shot or aerial shot together with CG elements. So all of the skyscrapers were added in CG and matched into the animated camera flight. But if you look at this very realistic representation, you see you have multiple different typologies of buildings. So you have these huge mega blocks, as they were called in the Dread universe. And then there are obviously some of the real building structures that were filmed on site. Is you have these bigger commercial buildings. Then in the back you have some larger, I don't know, hangars or things like that. And there are little shacks, little industrial buildings, and so on and so on. So a realistic city is a huge conglomerate of many building types, or so-called typologies, that follow their own internal structures and rules, how they are created and how they operate and how they are used. So let's have another look at the Hobbit movies. So what we see here is a still frame of Lake Town, and also here it becomes very clear that we see mainly one building typology, and that's this kind of residential / a little bit of commercial, because they're market commercial buildings, but they all kind of really follow the same structures, and there are really just a few elements that make up this building typology. So we see the sloped roof constructions, we see some of these towers with spires, and then maybe one of the main the main landmarks here, pretty much one of the only things, except for next to this bridge here that is a little bit standing out and is special to frame the shot, is this kind of, you could say, city hall or something like that. But it's very clear, so it's one unique type of town represented with one unique representation of a typology. The same thing here also with Fantastic Beasts. So this shot is, or a large portion of the movie is actually playing here in Paris, and so we see this typical Haussmannian building typology that very clearly tells you, yeah, this is supposed to be Paris. This shot, this story here plays in Paris. And if you count how many buildings of this style there are, it's pretty much everything. So there's, again, in this shot here, the art directors chose to choose just one typology to really make sure that people understand that this is supposed to play in Paris. And then there's one exception, that's the Sacré-Cœur, one of the most famous churches in Paris. And then back here, just faintly visible, is the Eiffel Tower, to root again the story in the location of Paris. So let's talk about the differences between typologies and how structurally we can represent different typologies looking at architecture or different types of architecture. So let's look at this building here. We will come back to this one. It's kind of a simplified representation of the Flatiron building. So one typical, or if you represent those buildings procedurally, what you typically start with is a building footprint. Then you extrude it to a volume, to the building height, and then this volume is actually subdivided into, in this case, into these three main volumes, with this little band or border that goes around the building to subdivide the ground floor from the middle floors, from the top part, and then this additional part up here that extends the roof a little bit further out. And then the detailing is added with different rhythms of windows and doors and things like that. Now, the lower example here, this Greek temple, is also here we start with a building footprint, and then the volume actually starts to get subdivided differently. So we have the first steps that is probably built from one solid volume again. Then we have the main volume, and then the roof volume with a tympanon and the sloped flat roof shapes on the side here, the sloped roof. which then gets detailed. So the main volume here especially is processed into these colonnades, into rows of columns. And then each of those volumes then gets processed further, where we insert these columns to actually build up the 3D model of the building. Now, looking at this kind of evolution process, we realize that multiple different building typologies follow completely different structures or rules. And looking at or comparing just these two examples together, it's very clear that if we have defined some of those rule sets, let's say, of, for example, for this more commercial skyscraper building, that if once we have developed the rules for one of these buildings, then we can replicate very similar buildings very, very often. And that's one of exactly of the advantages of a procedural system. And now if we have a rule set that is, for example, representing this temple here, then we can create many, many different variations of temples. But the difference are fundamentally, there's a fundamental difference between the topologies. Now, looking at another example here, a beautiful example by Epic Games. Obviously, it's been going through the media quite a lot lately, is the Matrix Awaken demo. But now, based on what we have learned, we can look at the building and we realize that the entire city is actually built just from one building typology that always kind of follows the same structure, very similar to the Paris scene that we have just seen before. Sure, there are certain elements that are different. Let's say, for example, this tower construction here, but we see that it will be repeated again here, 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 and so on and so on. So the whole city is again based on the same principles over and over and over. Now the question is this realistic? Well, comparing to the variation that you see in real world buildings or in the real world cities, it's probably not very realistic to have just one building typology, but it's certainly very, very efficient in the sense of developing automated system to create large amounts of 3D buildings. All right. Now, technology, taming the beast of architecture. So let's have a look at this example. So let's say we have a door and we have a wall. Just looking at how many ways there are to place this door just in this wall. We could place it in the left, we could place it on the right, in the middle, a little bit to the left, a little bit to the right, and so on, right? So there's already in this example here, you see that architecture has an infinite amount of variation that you can build with. And that's just a 2D, kind of a 2D problem here already. And it's already infinite. Now, looking at different, and that was just with one door. So let's have a look at different elements. So let's say a door and two windows. Now you can rearrange this again completely randomly, or you can start adding different types of windows, and they themselves can be oriented differently or arranged differently, and so on and so on. And obviously you see here the more types of elements that you have to play with, the more the more, or the exponential more variations of different design patterns you can actually realize. And this example here will show that some of those permutations actually don't make any sense whatsoever. So in this case here, it's like an ATM unit or ATM machine that is actually placed on top of a window, first of all, and then way too high, for example, for a pedestrian to actually get some cash here. So this example kind of shows that you cannot just randomly permutate everything. The permutations actually also have to make architectural sense and physiological sense. And so you start to see that 3D architecture is very complicated because you have to tame the beast, or you have to tame infinity. All right. So let's look at the Flatiron building that we just mentioned before, or where we have seen a first representation of. So let's also dive a little bit into the system of procedurally modeling something like this and what that would actually mean in reality. So let's look at the control attributes. So if you are a 3D artist, you typically have an art director that kind of dictates how stuff should look and what the control should be that we use for to drive the art. And in this case, because we are looking at a procedural system, we want to have a look at what are the control attributes. So one of the things that if we would want to create multiple buildings of this typology, what we would want to be able to drive is the building height. So that's pretty intuitive. Now, if we continue, we could also say, okay, we want to actually define the number of floors and the floor height. It's still also super intuitive to understand. Now, you can go further, obviously. You can say, okay, I want to actually separate that I can control the number of base floors. In this case, it's 2, independently of the rest of the upper floors, or of the number of that. Then the same thing for number of top floors. So at the moment it's 3, but I might want to have only 2 or maybe 6. Ground floor height. We could technically say that the ground floor have different heights than the upper floors. That's actually also the case here. We can go further. Obviously, we would want to potentially be able to drive the upper floor height, and so on. Now, going into we're going into more and more detail. Now, window types. There are at least like 6 or 7 or even 10 different types of windows. We have these very wide ones. We have these ones here. These are kind of in the middle. Then there on top here, there are these small ones that are, some of them are have a rounded arch or arc on top with a subdivision, and so on and so on. So they have different widths, they have different heights. And then there are different distances between them that we might want to drive. And then there are things like columns and pillars. Interestingly enough, there are some columns here, but not here and here. So these are things that we might want to drive. Obviously, then it continues with the decor, with the facade patterns. I'm not going into all of the detail, but you get the point. And now all of these elements here, the green ones and the yellow ones, all of those we have just described for one side of this one building. If you would want to drive the same parameters on the other side of a building, you would start duplicating kind of this whole set of probably at least 50 to 60 different control attributes to the other side. And if you would want to have individual control of those sides. And then introducing automatic setting of different parameters. There are these logical rules that you have to develop to develop a system that actually makes architectural sense. And as you start to see, this is quite tricky to do. Needs a lot of control and a lot of different steps to make sure that the stuff makes sense. All right. And obviously the last point here, you would not want to manually define all of these parameters for each individual building. All right. So what we see is there is a link between the number of buildings in a city, and if you want to automate many, or the creation of many buildings, you will kind of lose a little bit of the control in either the art direction or the architectural consistency. And every project has a little bit of a different balance in what your actual goal is. And this is something that you have to decide for each individual project. All right, let's talk about camera freedom in these 3D environments. So if you look at, for example, this beautiful image of the Griffith Observatory in Los Angeles, you see that if, for example, you have to create a visual effects shots for a movie, then you could say, okay, we need to create the observatory as a detailed 3D model, but the rest of the city doesn't actually need to be 3D. We could just create a painting in the far backdrop and just place this, because we just need to have the foreground in full 3D. Or we could also do some sort of a mixed system where we just place individual photographs of individual images or buildings onto separate cards, so that if, for example, the camera moves slightly in front of the observatory, we get some parallax effects in the far distance. And this might already be good enough for a shot like this. If your camera is relatively static and you cannot actually move kind of to the location back there. So that's obviously very typical if you're creating a movie. Then every single shot has a given camera position, and you can control how the image that is depicted is actually built. Now, if you are going into the direction of developing a 3D game where you can actually walk, for example, through an entire city, everything needs to be at the same level of quality. So if you can walk up to a building, let's say one of those buildings back there, you would want to be able to walk around this building, you would actually need to solve all of those problems with the awnings and with the deco and with the lights and the signage and so on and so on. So these are actually two examples of some German buildings that we did as a demo showcase some time ago. But these are kind of real-time capable 3D buildings. Now, so you start to see that if you have a completely, let's say, user-driven navigation where the user or the player, for example, can walk freely through an entire 3D city, you need to solve a lot more details than if you have a static camera that you have for example, a visual effects shot. And so the distance of the environment, of the architecture, the distance away from the camera, this lets you kind of go, how far can you cheat certain things? So if you're very far away from the camera, or if the objects are or the city is very far away, you can handle everything with a matte painting or with just a photograph of the backdrop. But as you get closer to the foreground, things need to be a little bit more detailed. So at some point you could say, okay, textured cubes for a city representation in the far distance, but you need to have a little bit of parallax effect. This could work well, or you have a textured terrain. And then the next step, for example, could be you have very rough building forms that are textured with a photograph from a far distance. You're also adding some roof furniture and very simple reflections in the facade to give it the impression that everything is built in 3D. And then if you get really, really close, you have obviously also things that you have to deal with is construction dimensions, dirt and weathering, asset distribution, signs, ads, electrical poles that are attached with their wires to the facades, and so on and so on and so on. So there's an exponential curve pretty much that defines the closer you are with the closer your architecture or your 3D environment gets to the camera, the exponentially more details you have to actually solve. All right, talking about the architecture. So architecture, as we have seen just in the schemas before, architecture can be very complicated, but it can also be beautiful. So what we see here is the style called Art Nouveau. So that was quite prevalent in, for example, in Europe, in multiple different countries in Europe around, let's say, the 1890s. So you see a lot of these very floral, beautiful deco patterns on the outside of the buildings, but also on the inside of the buildings, and both in constructions and also in paintings, for example. So there's a huge variety of architectural styles all around the world, and replicating these will really need a lot of kind of research in the trenches of what do you really need to develop, or what do you need to build assets wise, texture wise, 3D pattern wise, if you would like to go in this direction. Another beautiful example is, for example, the style called Art Deco. It's a little bit later than Art Nouveau, but this style has actually had, for example, huge influence on some of the earlier skyscrapers in America. And one of the beautiful analogies that I see here with these two specific examples that I just showed you with the Art Nouveau and the Art Deco is that they pretty much one-to-one or were taken one-to-one as the base in inspiration of architecture for, let's say, Rivendell, or for the Elvish architecture in Lord of the Rings and The Hobbit, and also with the dwarven fortresses and cities. So this, I think, is a these are two beautiful examples of taking a real-world architectural style and then kind of translating, transposing it into a fictional type of architecture. And I don't want to know how much effort and work went into this, but it's absolutely stunning work. All right, so let's talk about some solutions. In how do you tackle these types of projects, and what does it mean on the management side? I mean, obviously we cannot, because there's a plethora of different or many different types of projects, so there are no concrete solutions. We can only think about smart ways to manage and approach these different types of projects. And then there's always this management triangle where you can have two of the three sides. So you can have good and cheap, but the solution will not be fast. And I'm always amazed that not everybody knows this triangle, this management triangle, but you can always have two combinations. So you can have good and fast, but it will not be cheap, and so on. But you cannot have all of the three at the same time. Yeah, so fascinating. So I decided to actually add this in this presentation here. So talking a little bit more about the solutions. So one thing that is really important when starting to manage a 3D city project or a 3D environment project is project analysis. Is what do you really need? What is the task at hand? What is the scope? Then going kind of into the direction of smart management, try to do it really in a smart way. Assemble a strong team and consider also, for example, staff fluctuation. If you have a larger project that will run many months or even multiple years, consider those things. Try to assemble the best team possible that has different knowledge. Then obviously try to find the people, or you yourself dive into the technology to really understand solidly what the individual technical pieces do. Because if you want to go into the direction of automation, you will need to understand technology. And then obviously plan in a lot of spare or like breaks or buffer times, because everything always takes longer and is more expensive in the end, because you didn't consider everything. You couldn't specify everything from the get-go. So what I typically recommend to do is define and implement the absolute minimum first, so that you have kind of a full workflow, a full production pipeline, for example, or first results, and then build and expand on that. But it's better to finish something even in hobby projects or whichever project, it's better to finish something with all of the steps that are involved, but not yet at the full quality, than never finish something that is of high quality. Then also the costs. Obviously, the cost dimension is one of the most important ones. Try to use common sense and really try to dive into why are things so costly, or what could be the reasons behind that. So, for example, a few arguments here that I'm dealing with on a daily basis, also obviously in discussions with clients of ours. So, creating 3D urban environments is very technical. So you need to have people that, for example, are very strong in scripting or programming. So you're pretty much paying programmers to do these things. And then also these people, let's say technical directors, because they are programmer and creative at the same time, they are quite rare. So the team creation will take some time, which is obviously also costly. And then if you go in the creation of 3D environments, you need large amounts of assets and materials. So for a city, typically you have a couple of hundred 3D assets that you need to create, from lamp poles to containers to roof tiles to whatever it is. If you create a game, even you have to model characters or cars and vegetation and things like that. And it's an extra effort if everything has to actually be created with levels of detail. So that's a huge undertaking by just itself on the technological side and the creative side. And then, as we have seen, architecture is very, very complex, and streets, obviously, they are kind of intertwined between the architecture and or kind of interacts also with the architecture. So those are complex systems. And then, because we are creating so many different types of data, we need to really make sure that everybody, every artist, every programmer, every manager is very aware of file naming conventions and data structure. And you have to really make sure that you have that data in absolute consistency. Otherwise, it's going to be extremely a messy process, and you have to go back and fix things over and over and over again. And that can become really, really stressful if you're closer to a deadline. Then often marginalized is, I kind of just already mentioned it slightly, kind of going back and fix things or rework things takes tremendous efforts, or can take tremendous efforts. So this needs to be really well planned, especially if you want to add features that, for example, dictate that you need to rework an entire library of a couple of hundred 3D assets. This can take weeks of work with multiple people. And so this is, usually or very often this stuff is marginalized. And then also design reviews, kind of going in, reworking things, reworking designs. This can also, especially in the communication of how should artwork be implemented, this can very often be misunderstood. There are some things are sometimes lost in translation. So the time this stuff takes is usually also marginalized and not even calculated in, or not calculated well enough or precise enough in for example, project quotes. And then costs. Everything costs, right? So there's not only the work itself and then kind of the salaries, but there's also a lot of hardware involved, like 3D workstations with very good graphics cards, software, many software licenses, then the office, heating, snacks, and so on and so on. So all of those things need to be considered when you're going in the direction of creating complicated 3D environments. Then the research also of how do you approach things, which type of pipeline are you developing? Is it for a game? Is it for virtual production? Is it for film? Is it for advertisement? Then which types of architecture do you want to represent? You need to get some books or do some research online to actually track down what it is that you are actually wanting to develop. And obviously, very often this stuff is marginalized. All right, let's look at some costs of some of the most expensive but most successful games. So I just took out a couple of ones here. So one that I really liked is Watch Dogs, or actually there are more of those games, but this was from 2014. So that cost about $68 million US. Going up, for example, Shadow of the Tomb Raider, one of the latest ones, about, let's say, about 120 million US dollars. And then again, double that for Call of Duty. And that's just Modern Warfare 2. There are multiple of those games. This is just for the cost for one title with an existing, or pretty much an existing framework that was just improved for the next title, right? Costs $250 million. And you see that how incredible much work and love and dedication goes into these AAA games. And I've been in multiple situations where people approach me and said, "Hey, you're doing these 3D environments, and I'm interested to create something that looks photorealistic and kind of goes into the direction of those games. And I would like to create something." And then you are asking, well, what's a reference of a game, of a style of visuals that you like? And then, for example, one of the people said, well, Watch Dogs 2 is something that this person, or that he really likes. And I said, well, okay, but are you aware of how much this money costs to produce? How much this game costs to produce? And he said, I have no idea. I said, well over 60 million. And then there was quite a silence afterwards, because people don't realize, or a lot of people that are not, let's say, especially not professionally working in video games, for example, they don't know how much this cost. So yeah, consider these things. I think it's really, really important to look into the processes, the management processes also behind those products, behind those games, and not only into the artistic side of things, how you create individual assets or individual buildings. There's so much more going on behind the scenes. All right. Now, how do we come in with or what do we provide to help with these, let's say, challenges? So our second business unit, Urban Studios, is producing 3D content. So we have our shop, which you find under this URL here. And what we are doing is we are providing drag and drop high quality building models that are already done, in the sense of they are pre-built, they are really drag and drop finished 3D buildings. So no rework is needed, and they come in multiple different file formats and full PBR photorealistic materials. So you can actually use them in multiple contexts, from games to different types of visual effects, film productions, or advertisements, or autonomous driving simulations, and so on. Maybe a little detail, but it's actually very important, or I think it's very important, that our content is 100% self-made. This has some legal stipulations for people that don't want to run into legal issues or copyright legals or copyright issues. And then, briefly mentioned this before, so the content is available for offline rendering, so that's, for example, for VFX, and for real-time rendering at the same time. And we are providing multiple levels of detail for all of our buildings. And then because I think we live and breathe architecture, so the consistency of architecture is very, very important to us. And obviously also we've been hammering this point down with the multiple typologies. So we really look into the fact that we create multiple different building types, building typologies that actually work well together and are optimized together. Now, just a little kind of a hint or a shout out. At some point very soon, we will be also starting to release individual assets like, for example, lampposts or I don't know, cranes and containers and things like that, that are not necessarily connected to the building, but the rest of a 3D environment. So stay tuned for that stuff. Now, content. What we do for a couple of visuals, kind of to show which type of buildings and what type of content we are developing or can develop, is we have an internal kind of a visualization workflow where we take our tool agnostic building definition, and then we actually push this into a game engine. So this can be either Unreal or Unity, or we also have some importers for Houdini with Redshift, Houdini with V-Ray. We have an importer for Blender. We also have one for Modo. And at the moment, we're also working on, for example, Houdini for RenderMan and Clarice. So there's some work going into this. We're also looking into USD to bring it to even more tools. So if you're interested in more platforms, just reach out to us and let me know what you're interested in. And so let's have a look at the content. So as I mentioned before, our buildings have, the buildings that we create have multiple LODs. So in this case, it's actually 5 LODs. And I have a sequence of screenshots here that were made in the game engine called Unity. So this one here is the LOD 0. This is the highest LOD. Then the next one here is, this one here is LOD 1. So the idea is that you don't see a pop or only a very, very minimal between the LOD switches. So I'm going back to 0, 1, 0, 1. So you see it's shifting only slightly. A couple of pixels are shifting here on these railings. Then LOD 2, which is already dramatically reduced in complexity, but still very, very closely, obviously, represents the original data. Then LOD 3, which is the imposter that are kind of crossed planes. And then the LOD 4 is the kind of the billboard, which typically is very, very far away, let's say 1 kilometer away from the camera or even more. And this polygon usually also then orients towards the camera. Now, a couple of examples how those buildings look, or a couple of examples of buildings. On the left-hand side, you see a building represented in Unity, in the Unity game engine. And on the right-hand side, you see the same environment with the same building represented in Houdini with Redshift. So the left one is real-time visualization in a game engine. The right-hand side is offline rendering for example, for visual effects. Same thing here with a different building. On the left-hand side, you see the Unity representation. Right-hand side, you see the Houdini Redshift representation. Pretty much identical. Same thing here for a skyscraper. Again, the same story. Then assets. We have, as I mentioned before, we have a lot of standalone assets that can be placed also next to buildings, in alleyways and so on, or on streets. So this example here is a newspaper box, and our standalone assets actually ship with 3 levels of detail. Here's another example of a phone booth that is like, there's a lot of love going into all of those decals. We put a lot of effort into creating all of these details as realistically as possible. And here's some sort of oil tank asset, not the car, we just use this as a scale model, but this is also one of the assets that is kind of showing how far we go in the sense of realism. And this asset also again works for both the game world or the real-time world as also in the offline rendering world. All right, then just a quick word on the game demo. So taking some of the content, we have developed a game demo also in Unity, and you can actually download the executable for PC under this URL, vrbn.io/demo. And this demo looks approximately like this, or it looks like this. So what we did is we created this playable demo that showcases multiple different types of city parts. So we have kind of commercial areas, we have industrial areas, we have downtown areas. And for this, we created all of the streets, all of the street furniture. We placed a lot of vegetation and so on and so on. So the layout was actually inspired. So our architectural researcher and architect Anka, she studied some images of real-world city layouts, and she kind of analyzed the patterns and then created this resulting 3D environment or city part that is about 3.5 by 3.5 kilometers wide. That's about, let's say, 2.5 by 2.5 miles large. And then we, using the procedural modeling tool called City Engine, we have created multiple different types of urban layouting rules, procedural rules also, for industrial areas, for residential areas, for commercial areas, and then also for downtown areas. And all of those obviously use our internal libraries of the buildings and the assets that we are producing. And then everything gets collaged together. So what we see here is there are the different areas. Some of them are, I think the green ones are park. Then there are some that are more downtown, some of them that are more residential. So this is kind of the zoning distribution within this level that we created. And this obviously then is converted into, or based on this definition, we have then a fully procedural 3D environment that we can then push over into the game engine. So again, the URL, if you want to play with this yourself on a PC, then go to vrbn.io/demo. Just another quick word on virtual production. It's one of those very, very famous topics at the moment, where film production is more and more pushed into, or at least the pre-production and the shooting is pushed more and more using game engines and real-time camera tracking and representing the film sets, at least as a preview, in a real-time 3D environment. And this is a perfect application for our buildings, because our buildings are actually living in both of the worlds, both in real-time environments or in game engines. So you can actually have a real-time representation of a film set, for example. And then for the offline representation, for the photorealistic final frame rendering, you can go to a renderer and swap to the highest quality representation of a building and render the building in the final quality. Here's a screenshot, an interpretation, or not it's an impression kind of a couple of buildings ray traced in Unreal. So this is a game engine representation, just with some tweaked settings so that the images look photorealistic with true reflections. And then some more inspirations here with the combination of Houdini with Redshift, where we are ray tracing the scenes and where we have, for example, these urban areas like we see them here, or this one here with a little bit kind of after the rain, after heavy fog, or in heavy fog. Or this one here that I quite like is some sort of suburban area with a lot of vegetation and still kind of the wet floor also after the rain. And these renderings were actually derived from this environment here. Again, the environment here was created completely procedurally. And then what we added is a couple of assets that we manually placed, like some of the cranes, some of the oil tanks, and so on, strategically more important locations for certain camera angles. But otherwise, by far, the bulk was created procedurally, and this is actually the same framework that we used to create the game demo with. And another skyscraper visualization. I think it's quite an interesting and cool image. One more image of an industrial site, also just representing two large industrial buildings, this one here and the one that we are standing in front. One of the assets that we have developed is like a large gas tank. Then another representation that is a much larger environment. This one was also procedurally generated. It's not yet finished, so this is a test rendering, but the area here, including the terrain, is about 40 by 40 kilometers, so that's about 30 by 30 miles. And so the distance over the, let's say, the diagonal of the terrain, these skyscrapers back here, they are about 50 kilometers away, so it's quite a large environment. So this is about 35 to 40 miles away there. Very impressive, I would say. All right, so just kind of to slowly wrap things up, we are hiring senior software developers at the moment and technical 3D artists or TDs. So if you're interested to kind of work in this field, either now or in the upcoming months or at some point in next year, who knows, just reach out to us and we can have a chat. And this is it from my end. Thank you so much. Again, this was a presentation that I gave at the FMX conference 2022 in Stuttgart in May this year. And I just wanted to re-record this to also publish this to a wider audience. I really hope you liked it. If there are some questions or comments, just reach out to us at via the email address info@vrbn.io. Thank you so much for the attention. I hope you learned something with me today, and I'm really looking forward to hearing from you. And otherwise, we'll see you in the next presentation or video. Thank you so much.